Hello and welcome to this lesson in the Introduction to Geospatial Raster and Vector Data with R series. This is lesson 6 called Open and Plot Shapefiles in R. Our objectives for this lesson are for you to know the difference between point, line, and polygon vector elements, to be able to load point, line, and polygon shapefiles into R, and to access the attributes of a spatial object in R. So I have my RStudio window open and starting on a script, and I'll give it my title, Open and Plot Shapefiles in R. Give it my name and a date. And I'll be working in this script with the commands that we'll be using in the lesson. So I'm going to save my file. And I'm going to save it into the Geospatial Carp folder that we've been working in. And before I go further, I'm going to zoom in on the screen so you can hopefully see the commands a little better that way. And before we get started, I'm going to make sure that I'm in the working directory that I want to be in. So this may be redundant if you've opened a project that has put you in the Geospatial Carp directory, but this way, if I type it into my screen, I'll have it in my script, and I can always reuse the script later. So I've done a command enter to run the command. So now I'm in my directory. So now I'm in the Geospatial Carp working directory, which I also have displayed here in the Files window. So in this, starting with this episode, we're going to be moving away from working with raster data and start working with vector data. So in this lesson, we're going to open and plot point, line, and polygon vector data that's been stored in a shapefile format, and we'll open it in R. The data that we're going to work with refer to the Neon Harvard Forest Field site that we've been working with in the previous episodes. And in later episodes, we will learn how to work with raster and vector data together and combine them into a single plot. If you've been continuing with the previous lessons, you already have some libraries loaded that we'll be working with, but in the interest of having a script that will contain everything we need to have, we're going to type in the commands to reload the libraries so we have them. So we're using the library command, and we're going to use dplyr. We're going to use ggplot2. We're going to use the raster library. Again, I'm typing my commands into this window and then using a command enter to make the command load in the console. So in this lesson, we're going to start working with a new package, the SF package, which works with vector data in R. So we're going to use the library command to load SF. I don't know why that pound sign was there. In the RGDOL package, is supposed to automatically load when SF is loaded, but I see no harm in being redundant. And this way my script has the command to load the rgdal package even if it's not loaded with SF. So I like having those commands to be complete. And I'm saving my script. So the shapefiles we're going to import in this lesson are a polygon shapefile that represents our field site boundary, a line shapefile that represents the roads, and a point shapefile that represents the location of the Fisher Flux Tower located at the Neon Harvard Forest Field site. So the first shapefile that we're going to open contains the boundary of our study area, which we'll call the area of interest and abbreviated it to AOI and give it the name AOI boundary. So first we're going to import the boundary shapefile. To do that, we're going to use a command that's part of the SF package called stread. First, we'll create the name for our object to have our boundary file. So it's AOI underscore boundary underscore harv. Use the assignment operator and the st underscore read command. And we have to give it the path name, which is in the data folder, vector. And the file name, the shapefile name is harclip underscore utm z18.shp. Command enter. When we read in the harclip utmz18 shapefile layer into R, which we created as the AOI boundary harv object, the stread function automatically stores information about the data. And the information we're interested in, the geospatial metadata that describes the format, the CRS, the extent, and other components of the vector data, and the attributes which describe properties associated with each individual vector object. So the metadata that we're interested in for our shapefiles includes the object type, which is the class of the imported objects, the coordinate reference system, the CRS, which has information related to the projection of the data, and the extent, which is the spatial extent, the geographic area that the shapefile covers. And note that the spatial extent for a shapefile represents the combined extent for all the spatial objects in the shapefile. So there are three commands we can use to view shapefile metadata. It's stGeometryType, stCRS, and stBbox functions. And we'll go through these one at a time. So first, we're going to look at the geometry type for our AOI boundary shapefile. So use the command st underscore geometry underscore type using the autofill. And you give it our object name, AOI boundary harv. And command return. And so we see down in the console that it's a polygon object, and that there's 18 levels shown below the object, and these are the possible categories of the geometry type. Next, we're going to check what CRS our file is in. And if we remember from an earlier lesson that the CRS information connects the data to the Earth's surface using a mathematical model. And we can get more information about the CRS with the st underscore CRS function and we give it the name of our object, our AOI boundary harv, and then we use a method for this function, which is proj for string. And what we find here is our data is in the CRS UTM zone 18. We have information about the datum, and it's also important to note the units that your data is in this case meters. And so that's going to be relevant when we consider the object's extent. And if you're going to be working with multiple shapefiles and you're going to want to overlay them on one another, it's important that you be aware of the CRS information and that it matches among all your objects. So the next bit of metadata we're going to look at is the extent, and that's with the st_bbox function. So again, type in st_bbox, give it our object name, AOI boundary harv, command return, and what we see here is the spatial extent of our object, which is the geographic edges, locations that represent the furthest north, south, east, and west of our object. So it represents the overall geographic coverage of our spatial object. And we can quickly view all the metadata in the attributes for an object just by printing it to the screen. So there's our object name, AOI boundary harv, return, and we see very similar information to what we got one command at a time. We have the geometry type, we have its dimensions, and the CRS is represented as a code number which could be looked up for more information of what projection corresponds to this CRS code, and we know that it's a polygon object. Now, before we move on, I'm going to go back and make some annotations in my script. So that next time I come back, I'll remember what these commands are for. All right, and I'll save my script. Okay, next we're going to visualize the data in our object using the ggplot package. So unlike with raster data, we don't need to convert vector data to a data frame before we can plot with ggplot. So we're going to make a plot. We're going to customize our boundary plot by setting the size, color, and fill for our plot. And it's important to note that when plotting SF objects with ggplot, we need to use the coord_SF coordinate system. And you'll see that command when we visualize our plot. So we'll start out with ggplot, parens, plus geom_SF in our data equals the AOI underscore boundary harv object, size equals 3, it's for our line width, color equals black. I'm going to give it a fill equals cyan 1 plus we'll add a title, GG title. Change that. Plus ending it with the coord underscore SF. So I'm going to highlight all of these, do the command enter. And now our plot window is opened up. We can zoom in. There's the boundary plot, and with what we set with the thick black border and the cyan fill of our boundary and our title. So next, we have a challenge for you to try. So using the steps above, your challenge is to import the harv underscore roads and the harv tower underscore UTM 18N layers into R. So call the harv roads object lines underscore harv and call the harv tower underscore UTM 18N object point underscore harv. For each object, answer the following questions. What type of R spatial object is created when you import each layer? What is the CRS and extent for each object? Do these files contain points, lines, or polygons? And finally, how many spatial objects are in each file? So we suggest you pause this video while you try the challenge, and when you're ready, restart the video and we'll go through the steps. So now coming back, our first step will be to import the data. For our lines underscore harv object, we read in using st underscore read, path name data slash vector slash harv underscore roads dot shp. So there's no errors, so that looks good. Now we'll read in for the point object. So point underscore harv. We'll read in using strread. All right, that looks good. Next, we're going to check the geometry type of each object that we just imported. So again, the command that we use for that is the st underscore geometry type. And for an argument, give it the object's name. So lines harv. Command enter. And what you see here is that there are a number of multi-string geometry items. So given that this was a line spatial object, that's not unexpected. That has several line string items. And we'll check the geometry type of our other object. Our point harv. And there we see it has a point geometry object. And we also want to check the CRS and the extent of each object. So using the st_CRS command function and give it the object name and the method that just pulls out the projection string, which is proj_string. See, similar like our boundary object, it's in UTM zone 18 with units of meters. And we'll check the extent of our lines object. So that's the st_bbox lines_harv. So that was making our comment, that's check CRS and extents. And we'll do this for the point object as well. For our point harv, $, proj_string, command enter. Again, UTM 18 units meters. So that's good. And we'll check the extent. And to see the number of objects in each file, we can look back at the output from when we first read these objects into R. So I'm scrolling back, and here's where we read in the lines object. And we can see that it has 13 features. For our point object, we can see that it has 1 feature. So this is the end of lesson 6. What we've done is to look at point, line, and polygon vector elements by importing their shapefiles into R and by accessing the spatial attributes of these spatial objects in R.